Okay, Algebra 2. We're on day 3 notes. This is the first chapter still. I'll review, hopefully. Day 3 is all about systems of linear equations. Alright, what is a system of equations? It's just when you solve more than one equation all at the same time. A couple examples. You're going to see quite a few here in today's notes. Y equals negative 2x plus 8. Y equals x plus 2. Hopefully you recognize that these are both lines. Alright. Different ways to solve systems is graphically or algebraically. All right, graphing, graph paper, all that good stuff. Algebraically is where we have to show all of our work. Usually lots of steps for some of these. All right, some different types of answers that you're going to get. If you are, let's say you're graphing them, so you just have two lines, you graph them, doesn't matter what they are, just you're going to get a picture, right? Your answer is the point of intersection. Don't forget that. So your answer could be a point. Right, most of the time it is. It's like an XY coordinate. Make sure you get both the X and the Y. All right, so maybe once in a while you're going to get something else though. Say you get two lines that never cross each other. All right, think about what's your answer then. If it's a systems of equations, you're going to say no solution. All right, if they never cross, there is no answer. So no solution. This keeps going on the next page. All right, so if they cross once, they could be, what if they're the same line? So, hard to show, I also have his pen here. So if it's one line and then the same line over the top of it, all right, they end up being the same in line. How many answers do you have? All right, if you're thinking infinite solutions. So once in a while you can get that as well. Infinite solutions. For graphing, like I said, you just have to graph them both. So step one would be graph both equations. And find your point of intersection. That would be your answer. Later on in the year, we're going to start doing more than just lines, so it's going to be a little bit more work, but same idea. You could have more than one point of intersection. Algebraically, some different options here. We could do the substitution method. And the other one you might remember is the elimination method. All right, another name for the elimination method was the addition method. So basically just adding the two equations together. We'll do an example, not that bad. Say we're going to solve them graphically. We'll just start this one, I guess. So you got two things, say your two equations. Again, hopefully you can tell that they're lines. There's no squared term. Y minus x equals negative 2. If you remember anything from Algebra 1, you have to get y by itself. Move that one over here. So I'm going to add this x to the other side. I'm not going to show any work though, that's all right. So y equals x minus 2. There's one equation. This one we can solve for y real quick. Move things around. I'm going to add this 3x to the other side. So now 3y equals 3x plus 9. Divide by 3 everywhere. So y equals x plus 3. So I've got this equation. I got this equation. You could graph them all. It takes forever. It's all right. Calculate if you really wanted to. Maybe you're thinking, maybe not. I don't know. What do you notice about these two lines? Y equals x minus 2, y equals x plus 3. Hopefully you're thinking they got the same slope. So are they ever going to cross each other? Right? They got different y-intercepts. Same slope, never going to cross. So right off the bat, without even graphing it, I'm going to say no solution. All right? Doesn't happen often, but once in a while. Let's do another one. Number 2, I'm going to let you graph that one. Go ahead and graph that one. We'll go over that in class. Let's do the algebraically. A little bit of work for these. Solve algebraically. So depending on how it's set up, pretty much leads you to which method you want to choose. Just by looking at number 3, y equals x minus 2, 3x minus y equals 16. They're telling you y is x minus 2. So I'm going to use substitution. I'm going to take this x minus 2, right? That's y. I'm going to plug it in for this y right here. So everywhere I see a y, I'm going to put an x minus 2. So 3x stays minus, I'm going to put all of it in there, x minus 2. I would use parentheses because your signs will mess you up otherwise. All right, equals 16. Distribute. Be careful, little mistakes. All right, a lot of you can do this, but what can you do without making mistakes is key. Don't be afraid to show some work. Combine like terms. All right, some of you like to show everything. That's fine, nothing wrong with that. You made it to algebra 2, though. I'm assuming you can subtract 2 in your head to their side. That's fine as well. All right, you get x equals 7. All right, a lot of people mess this up because you're gonna stop right there. You think you have the answer. That's great and all. X is 7. You need to solve for y though, because remember this is like a point on a graph. It's an xy coordinate. So if x is 7, use one of your equations. Obviously the top one's easier to work with. So find y. Y is x minus 2. So y is 7 minus 2. Y must be 5. So there's your answer, right? Sometimes it says leave it as x and y. Most of the time it wants it as an ordered pair, though. The 0.75 is your answer. It's a parenthesis. Yikes. Try number 4, see what you get. Same idea, a's and b's, doesn't matter. Same as x and y. Works the same way. Treat it like an a-b coordinate, I guess. All sorts of examples. Number 4 on the next page. Just by looking at the way this one's set up, 3x plus 2 equals 4, 4x plus 3y equals 7. You could solve for x or y on one of these if you wanted to, but it's going to be more work than necessary. Let's do the elimination method, right, or the addition method. There's no coefficients that are the same right now, so you got to do a little bit of work. I don't know, just pick one. Which one do you want to get rid of, x or y? I'm going to start with y. Let's stick with it, right? So if I have a 2 and a 3 here, I'm going to think about getting a 6 there instead. So in order to go to 2 to a 6, I'm going to multiply all this by 3. And then you don't want the same coefficient, you actually want opposites. So I'm going to make this one a negative 6. So multiply all this by negative 2. All right, don't be afraid to show some work, rewrite it. Hope you got some room on your paper. Multiply everything out. Even the other side equal sign gets multiplied. It has to be the same equation, written differently. So 9x plus 6y is 12. Negative 8x minus 6y equals negative 14. All right, you do want the opposite signs. That way we can add them. We don't have to do any thinking. All right, this works out nicely. That goes away. That's what we want. We want one of those to disappear. 9x minus 8x is just x. 12 minus 14 is negative 2. All right, so it works out fairly simply. You have x now. How do you solve for y? Just pick one of those original equations to start with. I don't know, say you use 3x plus 2y equals 4. You have x, plug it in. Simplify. You get y. All right, so there's your xy coordinates, negative 2, 5. All right, try number 5. Get you started. This one looks a little bit different. I would line up my x's, line up my y's, right? Get everything lined up before you start doing the elimination method. Give it a shot, see what you get. The last few are word problems. Maybe I'll get you set up. I'm gonna let you guys do these. We'll go over them in class. Number 6, like an Algebra 1 Regents question probably. All right, these are always on there. You buy 3 tarts, 5 cookies, pay $10.50. Same price. Lisa has 4 tarts and 8 cookies, paid $14.80. What are the prices of each? So maybe I want to say let x equal, doesn't matter what letter you use, I guess. X is tarts. Let's say C, but I will go Y. Y is cookies. All right, so set up your system. 3 tarts, so 3x, and 5 cookies, so plus 5y. That's $10.50. Lisa got 4x plus 8y. She paid $14.80. All right, so we are using x's and y's. There's your system. Just the way it's set up, I would use the addition method. All right, try to eliminate one of those variables, pick one and go with it. And a little bit of work, not the same coefficients. I'll let you guys try that one. Try to finish that one. All right, so we'll go over lots of these in the notes or in class. The last one, same idea. I'll let you do it. Number 7. Number 7, same idea. You got more tickets here, looks like. All right, student tickets, regular tickets. All right, total receipt. So some people, I'll get you started. Let X equals student tickets. Let's say Y is the regular tickets. All right, some people forget this one. You always think about the money one. All right, you've got student tickets, $250 each, so $250 X. Regular tickets, $375 Y, for the total amount of $1125. All right, some people maybe forgot, it's been a while since Algebra 1. Where's this 425 go? And what kind of equation? I only have one equation. I need another one, right, to make it a system. It just says the total number of people going for 425. So that's students and regular people already. So that's your other equation, is X plus Y equals 425. All right, I'll let you figure out whichever way you want to use. This one, elimination, maybe kind of messy. Maybe you want to solve for X or Y and plug it back in. Try substitution method. Give it a shot, see what you get.